In this segment, we're going to talk about the inverse square law. The inverse square law is a law that tells us that the quantity and the strength will decrease with the square of the distance from the source. What we mean by quantity is a number, such as 1, 2, 20, 45, 110. And what we mean by strength is the strength of a property, such as gravity, or brightness of a light bulb, or brightness of a star. And the key word here in this law is decrease. So the quantity and the strength will always decrease as you step away from the source. Let's do an example. So let's say we have a cake, and on this cake we have 16 candles. So the quantity is 16. And the strength, the property we're going to look at is the brightness. So we want to know, what is the brightness of the cake? Well, the brightness is equal to 16 times the luminosity of one candle. So let's put you 1 foot away from the cake. You're standing at the cake, you're looking at the cake, and you see 16 candles on it, and it appears very bright. It appears the brightness of 16 candles. And let's say you stepped back 1 more foot. How bright does the cake appear to you now? Well, the inverse square law tells us that the brightness will decrease. So the cake won't appear as bright to you. You stepped 1 more foot further away, the cake appears dimmer. So you were at 1 foot, and then you went to 2 feet, or you doubled your distance. So you doubled your distance, so double means 2, but notice that we have the square of the distance in the law. So we're really looking for d squared, and d squared is 4. So how bright does the cake now appear that you doubled your distance from the original 16 candle cake? Well, the cake now appears to have 4 candles on it. Or the cake appears to be as bright as a cake of 4 candles. So the brightness decreased. It went from the brightness of 16 candles to the brightness of a cake that had only 4 candles on it. So the brightness decreased from the brightness of 16 times the luminosity of a candle to the brightness of 4 times the luminosity of a candle. Or it went from 16 times the initial luminosity to 4 times the initial luminosity, or it decreased to a final amount of 1/4 the original amount. So the final brightness is 4 over 16, or 1/4 of the original brightness. So the number would be the equivalent of saying I had 16 candles on the cake and I doubled my distance away, so now my cake appears to have the brightness of 4 candles. So the quantity decreased from 16 to 4. Let's do another example. Let's say you have a cake that has only 9 candles on it. So the original quantity is 9 candles. And once again, you are standing 1 foot away from the light source of 9 candles. And let's say instead of just taking 1 step back, you took 2 steps back. So you went from 1 foot away to now 3 feet away. In other words, your distance tripled. You went from 1 feet to 2 feet, and that doubled your distance. Then you went to 3 feet, and that tripled your distance. So d is now 3. But we want the square of the distance, which is 3 squared, or 9. So what is the brightness now? If the brightness originally was that of 9 candles, what is the brightness now? Well, the brightness now is the original 9 candles divided by d squared, which is 9, or 1. So to you, it looks like you have a cake that has only 1 candle on it. So when you step away from your source, the brightness decreased, and it decreased by the amount of the square of the distance. In this case, your distance tripled, and so the square of the triple is 9, And so if you had 9 candles on it and you divide by the triple, which is 9, you get an answer of 1. And so it appears to you that the brightness is now 1/9. The brightness is now that of 1 candle, or 1/9 the original amount. So the brightness decreased from the brightness of 9 candles to the brightness of 1 candle, or now it's 1/9 the brightness of the original amount. Let's do another example. Let's look at gravity, and let's look at the gravitational force between 2 stars. Let's say we have a red star, and let's say we have a blue star. And the red and blue star are a distance d apart. Now the 2 stars feel a gravitational force. It's an attractive force. The blue star is pulled towards the red star is pulled towards the blue star. So it's a gravitational force. Now let's say we move the blue star out to double the distance. So we're going to move the blue star away from the rest of the red star and adding another d away, or double the distance. By how much did the gravitational force go up or down? Well, the inverse square law tells us that as you step away from the original source, the quantity and strength will always decrease. So we know that the gravitational force will go down, but by how much will it go down? Well, since we went from d to 2d, so we're now twice the distance away. So we were at d, and now we're at a distance of 2d, or double the distance. And the inverse square law tells us it's the square of the distance. So the distance now went to 2d, and now the square of the distance is 2 squared, or 4. Then the original force of gravity is going to be decreased by 1/4, and so the final gravitational force will be 1/4 the original gravitational force. So if you have this blue star out here, then the force of gravity is 1/4 the original force of gravity when it was a distance of d apart. Let's do another example. Let's look at the sun and the earth. The sun is this bright big yellow object in the sky, and the earth will draw as a tiny blue dot. Now the distance between the center of the earth to the center of the sun is 1 astronomical unit. Now the force of attraction between the earth and the sun is just the force due to gravity. And what we want to find out is if we move the earth, let's move the earth at a distance of 3d away. So we went from 1 AU, we're going to move it out another AU, and then move it out again another AU. So we went from 1 AU to 3 AU, or we tripled our distance. So d is now equal to 3 because we tripled our distance, or we went to 3 AU. So since the inverse square law tells us the square of the distance, we're looking for the distance squared, which is 3 squared, or 9. And since it's telling us that the strength will decrease, we know that the force of gravity initially is force of gravity, and now we're decreasing it by 9. So the final force of gravity is 1/9 the original force of gravity, which you may like it better as just putting 1/9 the original force of gravity. So the final gravity is 1/9 the initial gravity.